I repeated the test 1 measurements with 2 changes. Firstly, they were done on a part of the test range where there is a slight depression in the asphalt surface. And secondly, I used horizontal polarization instead of vertical. Here are the results. There is a noticeable power drop as the receive antenna moves through the depression and the power recovers on the other side of the depression. The depression starts at about 30 meters from the transmit antenna and it finishes at about 70 meters away, give or take. The missing piece is that I didn't use the model to simulate the road depression, so there's no direct comparison between predicted and measured power levels here. But what we can do is change the height of the receive antenna until the ideal curve matches the measurements. And by making this adjustment, the predicted curve is a good match to the measurements from about 30 meters to 60 meters, so that's a pretty good agreement. If the depression is about 15 centimeters deep, which seems sensible based on what I saw there. In the reverse direction, if we raise the height of the receive antenna, the best match at long range occurs when the receive antenna is about 20 centimeters above a flat reference plane. It seems that the depression is maybe 15 centimeters deep, and on the opposite side, the roadbed rises until it's about 20 centimeters above a flat reference plane. I should have used a laser to measure the actual road contour because these measurements suggest that it might be possible to estimate surface flatness by measuring power versus range if the transmit and receive antenna heights are known. As it stands, these measurements are, let's say, indirect evidence that the propagation model has predictive value in that the deviation of the measurements from the predicted power for a flat surface are in the direction that's predicted by the model. And as a last point, if we zoom in on the part of the test range that's flat, maybe the first 30 meters is, the agreement is very good for horizontal polarization, more or less as good as for vertical polarization in test 1.